Perfect. So again, I strongly recommend, if you don't like this table, you're not going to hurt my feelings, but it's a super important table. So I'm hoping that you're going to eventually get used to it. Okay, so I want to start with this. Again, don't cross them out like that. There is no need. So 0 is somewhere here, so f of 3 is 4. So this is done. I'll continue with 3 because it says the limit as x approaches 3 from the left is 1. Inside the parenthesis, this is 1. On the right-hand side, with values of x greater than 3 from this side is 4, which obviously says to me that this is continuous from the right of 3. That's very clear. Then it says limit as x approaches infinity of f of x is 1, which means y equals 1 is a horizontal asymptote. Then we also have, as x approaches negative infinity, it approaches negative 1. Done with this as well. Y equals negative 1, horizontal asymptote at negative infinity only. At infinity only. So this is very clear. This is very clear. And this is here very clear. Okay, what else I have? I have 0. I have 0 from the left, which is infinity. And I have 0 from the right, which is negative infinity. All are accounted for. Obviously, x equals 0 is a VA. Now, this should be very clear to us. Everything is organized. Everything is taken care of. I know exactly what I have to present. So now let's go ahead and do this. Okay, it says horizontal asymptote at negative infinity is negative 1, but I cannot just do this. Y equals negative 1 is this line. But it will only mean something to us here. So this is y equals negative 1. As x approaches negative infinity, the function value will approach negative 1. I'll get to it, either from above or from below. I don't care. A function can cross a horizontal asymptote. It will never cross a vertical, though. Okay, so here I have a vertical, which is x equals 0. There is no point in drawing it again because this is the y-axis. On the left-hand side to infinity. Okay, so now I know I'm going to just draw something very simple. This is it. As x approaches negative infinity, the function values approach negative 1. As x approaches 0 from the left, the function values approach infinity. So this is done. On the other side, now I want to jump here for a second because it says that it has a horizontal asymptote at infinity only. I also have 3, 4. So if this is 1, 1, 2, 3, 1, 2, 3, 4, right here, this is the point. Which point? This one. On the left-hand side, it's coming from negative infinity and approaches 1, but it has to be an open point. And I'm going to draw just something very simple. Negative infinity on this side and approaches 1 at 3. On the left-hand side of 3, it approaches 1. On this side, the point is here because 3, 4 is also here, and it approaches 1. Very simple. This is my f of x. There is more than one correct answer. This is not the only one. You can do so many different other things with it. It's up to you. I drew probably one of the simplest possible functions that fulfills all the given information. Anything else? Any questions on this, first of all? Any questions? Yes, go ahead, please.
You said that there's many different options. Can you show an example of a different option?
Sure. I'm just going to use pencil so I can erase it. I may not be able to see it. Any questions? Is this okay?
Absolutely, I have a question.
Yes.
Where did the asymptotes come from just now?
The ones that I just created?
Yes.
I can do whatever I want as long as these are fixed. I can create any asymptotes anywhere I want. I can put max, min. I can add on millions of other things as long as these are fulfilled.
Got it.
I'm not told what to do with the rest. I am told whatever you graph has to fit this. The rest is in your hands.
Would anybody ever do that? Like, is there a reason to ever?
There are millions of functions. There are millions of functions that fulfill the given information. You can choose the one you like. You're only required to stick with what you have. Then in the middle, you can create whatever you want. It just says an example of a function that fulfills the given information. The rest is your creation. Anything you want to put in there, it will work as long as you're not changing the given information. Everything else, you can do whatever. As long as it's a function. Good. Anything else? Isaac, did you find it? You said you had a question for me? Sean, is this okay? Did you have another question?
No, I'll send the screenshot at the end of class.
Okay. As long as, if you find it, you know, at the end of the class, it's just going to be me and you. So if you find it sooner, just send it my way sooner, okay?
Okay, I'm doing it right now.
As long as, I mean, it doesn't have to be the second. I'm just going to share my screen and then go back to 2.7 so we can finish up. We have many other topics to look at, different other problems, etc., etc. Okay? So we are back to 2.7. We did not get the chance to look at, oh, yes. Here it is. I'm sorry. We can't forget about this. This is our second best friend. We want to find f prime of x for this function. How do we start?
Could you write it the square root of x plus x to the 1/2 power?
Yes, but it will not help. Yes, I completely agree. This is indeed correct. But it will not help in this case. But yes, absolutely. Many times we do this. Yes, I agree. So we're trying to find the derivative. What did we say? How did we create the derivative? What is the derivative composed of? That's how my markers get dry, because I'm waiting for my students.
It's the difference quotient.
But there is something else. There are two topics that we put together for this. right?
So it's the difference quotient and the limit.
Yes. The limit as h approaches 0 from f of x plus h minus f of x divided by h. You have to dream about this definition. The limit with the difference quotient together. That's the derivative. Good. So then we have limit as h approaches 0. Can anyone help? Please. Everyone has to speak. Rihanna, will you start for us, please? Rihanna, are you with us?
Yeah, sorry, I was copying it down.
That's okay. How do we
Okay, so
start?
we're plugging in 0, right?
I haven't even written anything yet.
So we're putting the square root of x in there.
So just tell me what to write.
So square root of x plus h.
Awesome.
minus square root of
Yes.
x. Yeah. Okay.
Awesome. And now you're completely correct. I plug in 0 and for age. And what do I get? Awesome. Anyone else? RJ. RJ,
Yes.
so what do we get?
To plug 0.
Say it again.
Do plug 0 into h.
Yeah, so what do we get when we do that?
You get square root x minus 0 over 0.
Excellent. Well done. Perfect. So then what do we do? What is our next step then? Ethan, what do you think?
It means that there's hope for it.
That's true. We better, because that's a derivative of a function. Yes? Good. How do we continue? Look at this and say, oh, I know. Anyone would like to suggest?
Get rid of the square roots. So multiply by the reciprocal.
Very good. Awesome. Well done. Indeed, the square root of x plus h plus the square root of x, the square root of x plus h plus the square root of x. Please rewatch my videos. I know they're not the best quality, but they will help you. Please, I'm begging you. I don't mind begging. I stopped being embarrassed a long time ago, about 20 years ago. Okay, the denominator is h, the square root of x plus h plus the square root of x. Can anyone help with the numerator?
The numerator is going to be x plus h minus x.
Great job, Brian. Thank you. So these two go away as expected. All terms without x have to go away. And then eventually these two, but I'm not going to cross it out there. I'll have to write it again.
I think I got a little lost where you canceled out the x's.
You have an apple and you give it to me. Then you have no more apples.
From the previous time.
Ah. Please rewatch my videos. I'm begging you. On the first day of classes, we said that a plus b times a minus b is a squared minus b squared. So if this is a and this is b, I square a and I get this. I have to copy minus. I square this and I get that.
Okay.
Please. I'm begging you. I don't mind. So now It's part of my job. It's been part of my job for a long time. So now, please, can anyone give us the answer?
One over x square root of x plus h plus square root of x.
When we apply this operator here, what do we actually do?
Ooh, oh, I see. Oh, 1 over 2 square root x.
Awesome, brilliant. That's it. You see the problem here? So the square root of x is not differentiable because the function, the derivative does not exist at 0, not differentiable at x equals 0. So now moving forward, please remember the square root of x prime is 1 over 2 the square root of x. Carved in stone. Okay. Any questions before we move on?